Stoichiometry. It's a Joycey thing. It isn't, but
it just, I get what you're saying.
Stoichio means element, and this means to measure. So you're measuring elements, essentially. Okay? It all comes down to ratios. Okay? So when we were doing the BCA tables with you, we were trying to show you ratios. There's different ways to do this. I don't really care which approach you take. Some people do it with dimensional analysis. I like to do it with those BCA tables because when we get into Unit 7 and we're doing equilibrium, they make ICE tables easy. So if you understand how to do BCA tables, when we get to ICE tables in Unit 7, life is easier for you. Okay? Essentially, you are looking at doing mole to mole ratios. Okay? It can also be done with gases, and you can do liter to liter or volume to volume ratios as well. Your coefficients are used for those ratios. Right? So sometimes they give you stuff as far as your reactants, and you've got to figure out products. Sometimes they give you products and they want to know how much reactants you got to start with. There is a concept, and this got many of you on the test, which was a percent yield question as opposed to a percent error. You saw percent and you went right to percent error. You did not read the question. Okay? So actual over theoretical times 100, typically it's going to be less than 100%. Okay? So again, percent yield, actual over theoretical times 100. You are awesome. Thank you, sir. Oh, you're welcome. All right. So here is an example. We have hydrogen peroxide that is decomposing, and they want to know how many grams of water will be produced. So first of all, we can't work with grams. Okay? We have to turn grams into moles. Remember, only moles and holes. Okay? So when we're doing our BCA tables, we need to get these things into moles. Okay, so BC. We're starting out with 0 of each of these. We've got to figure out how many grams this is. So we're going to divide this by mass of hydrogen peroxide, 3234. So 1 divided by 34. No? I'm going to do it for me. Do my own work.
Sorry, Libby. I'm like in my own little
1 divided by 34. I got. Okay, and make sure when you're using this BCA table, you have at least 3 significant figures in there. Okay, otherwise this kind of starts to fall apart. So I have, for my hydrogen peroxide, 0 to 9. How many sig figs do I have right now? 2. I want 1 more. Okay. Now, we need to go up into the cloud. How do we get into the cloud? Divide by the coefficient. So I'm going to divide this value by 2. That is going to give me a cloud value of 0.0147. And now I'm going to bring that back down. I'm going to use up all of this. I'm going to add this times 2. Oh, crap. It just changed slides. Okay. I was trying to erase that line so I can give myself more room. And I ended up changing the whole stupid thing. Okay. And then this is going to be plus how much?
0.147.
Yep. No, 0.147. Okay. So we made Okay? And we don't have any of that left over. Now, when you are doing these on a test, did they ask me anything about oxygen here? No, don't bother with that. Okay? Once you get to this point, can you tell how much of this, how many moles of this you have? We started with 0. We have this. Is this going to be the same answer? Yeah. Don't bother writing this down then. Save yourself time. Okay? So if you can do this math, just even at the top, being able to do it without having to write out a whole table, go for it. Okay? Save yourself time. Show them something, though. Don't just give them an answer, because if you just give them an answer, they're going to mark it. It's gone. It's done. You have to show them a little bit of work. So show them what your thought process is. But if you can do that, you know, write down your mole here, write down that, write down this over here, you know, go up and over and get that. It's fine. That's enough. Does that make sense? If you need to do the whole table to get the right answer, do it. Okay? But if you want to, if you're able to save a little bit of time, save it. Yep. So when you are working with these, your reactants are going to get used up. So you're using all of that up to make this stuff. So use piece of junk. I hate this stupid thing every day.
Happy Thursday, Lippy.
Happy Thursday. So I started out with this stuff. I didn't have any of these things originally. So by using this up with the minus, okay, I'm making these things. So these are called BCA tables, before, change, after, depending on who you had teach you Stoic. It's ratios, though. And I think your math is where you need to be able to do kind of fast ratios. So you may not even need a whole table for that. Okay? All right. Have I answered the question yet? No. I have my moles, but I don't have my grams. So I need to multiply this by what? 18. Okay? Do I need to do fancy dimensional analysis to get that? If you don't do it. If you still need it, though, do it. Okay? So 0.0294 moles of H2O. I want to get rid of moles, and I want to go into grams. And for every 18 grams, I have 1 mole. So I ended up with my answer. Hopefully I got it right. Let's see how many sig figs I need to use. I need to use 2 sig figs. So 5, 3, and that's going to be grams of water. Yes? Is that what you got? Anybody going to verify my answer? Okay.
Where did you find those sig figs?
It was my measured amount that we started with up here. So that gives me 2 sig figs. Always go back to your measured amount to figure out your sig figs. And wait to the very, very end to round it for that value. Like, don't do it, because if you do it all the way along the way, you're going to end up rounding out a lot of stuff, and you're not going to come up with a good amount.
Don't spill it.
I spilled my drink at home last time. I'm like, oh no, it's starting again.
Okay, this is a stupid
No, it's not.
question.
Just ask me, honey.
Where did we get the 34 from? Is
30.
that just at,
4. Oh,
yeah, that we
I added, so this is hydrogen peroxide.
Yeah.
So 2 hydrogens, that's 1 times 2, and 2 oxygens is 2 times 16.
Oh, okay.
And so you add that together, and that gets you your 34.
That's what I thought. But I just...
No, it's okay. Slow me down.
It's
Sometimes I need to be slowed
No,
down.
this is me today. This is
But that's
my
okay.
mental game today.
But other people might be in the same spot, and they're not brave enough to ask. Then they need to, ask. Slow me down, okay? I jump.
Yeah.
Okay?
It's just a morning.
It's okay. Do it. Just slow me down. I've had my first cup of coffee. I'm just, like a little bunny rabbit. I'm just, so slow me down. All right. Any other questions on this problem? All right. Here is a limiting reactant. Okay. So here you have to figure out what you're going to run out of first. Okay. Again, depending on who did your stoich, you might have done this as a very lengthy dimensional analysis set of problems. But the BCA tables save you time with that. I'm going to rewrite this so I have a little bit of room to show you what's going on. All right. We are reacting 15 grams of iron with 6.5 liters of oxygen at STP. How many grams of rust would form? Okay. So I need to, what is the number? What is the number? Is it 22.4? Crap. No, not iron. I am talking about Avogadro's principle. It says that if we are at STP, this is unit 2. Where's my unit 4? Is this my unit 4? This is honors. Here we go.
Oh, no.
Here we go.
No.
Okay.
I'm like,
So we have been given grams here, and we have been given liters. Okay. But we are very fortunate in the fact that they have told us that we are at STP. Okay. So we are going to use a couple different ways to get these things into moles. Okay. The first thing we're going to do is we're going to take 15 grams. This is iron. So we are going to divide that by the mass of iron. So the mass of iron off the periodic table is 55.9. So if I divide 15 by 55.9, I'm going to end up with 0.270 moles of iron. So that is what I am starting with. Now, we are also starting with a certain amount of oxygen. We need to get that into moles. Okay? Now, Avogadro's principle states that if we are at STP, which is standard temperature and pressure, you learned about that during the gas unit last year, which I think is chapter 13, or the year before, whenever you had me, or whoever you had. Okay? It says that if we have 1 liter of gas, that is going to be equal to 22.4 moles of that gas. That is Avogadro's principle. And I want to say that is on your sheet.
It is.
Yes, it's the very bottom thing in the gases, liquids, and solutions section here. Okay, so this is on your formula sheet, this here. But again, it says at STP. So if you're not at STP, then you got to go in and do the good old ideal gas law formula. Okay? Yeah. And it doesn't matter the identity of the gas. So this could be oxygen, helium, hydrogen, argon. It's irrelevant. The identity of the gas is at STP, 1 liter of gas will be that many moles, period. Okay? So if I know that I have 6.5 liters of gas, for every 1 liter of gas, I have 22.4 moles of that gas. Okay? Yes?
Does the 1 liter equals 22.4 moles? Does that only work for gas?
It only works for gases, yes. Yep. You can only use it for gases. But oxygen is a gas. They told us that in the problem here, right here. Okay, so it works. So we are going to multiply across, divide by the 1 in the bottom, and we end up with, did I set this up wrong?
I think it's 1 mole equals 22.4 liters.
Oh. Yeah, maybe I set that up wrong. I'm sorry. Liters per mole. Yes, you are correct. I'm sorry. I had this backwards. I'm sorry, guys. Okay, so 1 mole equals 22.4 liters. There we go. Now we're better. I'm sorry. I'd say it's a Monday, but it's actually a Thursday, so I'll give you a second to erase and fill in. Anybody need liquid paper? Like, correct? Well, it used to be called liquid paper. It's called correction. Yeah, whiteout. The original company that came up with this idea, it was called liquid paper back in the day. And it came in this little bottle and it had a brush, so it was liquid, and you would and you would brush it on.
And wait for it to dry.
Then you had to wait for it to dry before you could, go back over it and use. And well, for some of us old people, we still call it liquid paper occasionally when we're not thinking.
My grandma still has like legit liquid paper.
Yeah, and it's
She
probably
doesn't like
crusted.
the-
So, all right. So when I divide this out, I get 0.029. No, 0.29. Yeah, 0.29. No, that was the previous problem. Hold on. 0.29. There we go. All right. Everybody good?
I was gonna say there's gonna be a 0.
Everybody happy? Okay. Now, we have to figure out our limiting reactant. So what we're going to do is we're going to take these up into the cloud. How do we get to the cloud again? Divide by the coefficient. So I'm going to divide this guy by 4, and I'm going to create a cloud. Okay? When I do that, I get 0.0675. And I'm going to do the same thing for this guy. I'm going to create a cloud up here. And he is 0.0967. All right. You're going to get rid of all but the smallest cloud. So I'm going to get rid of this cloud, and the rest of my processes, I'm going to use the cloud that's left over. Okay? Get rid of all but the smallest cloud and use that for your calculations. And then the cloud that you keep, that is called your limiting reactant. This is what's going to keep you from making more stuff. Okay? If you use the wrong cloud, then your after column is going to have a negative value in it. So you know you've goofed something. Because your after column can't have less than what you started with. All right. So when I am done, there will be, I'm going to use up all of this. I'm going to multiply through the coefficients to get these values. So I got to take this and multiply by 3. And I got to take that and multiply by 2 to get this next answer. Now I'm going to be making this stuff and using this up. So this is 0.203. And this is 0.135. And I'm going to have some of this left over. So this is called my excess reactant. But they don't care about that. They only care about what? What's the problem asking about?
Rust.
Okay, so this is my rust here. And they want to know grams. So I'm going to multiply this by the molar mass, which is 159.7. And that's going to give me 21 grams of rust. Oops, got my coefficients backwards. Two sig figs, because I started with 2 sig figs for my measured amounts. Oh, God dang piece of junk. All right, any mess ups on where you don't know where numbers came from, anything that we need to talk through? Andrew, did you lose this in your backpack?
No, I didn't. I kept it.
Sometimes this liquid can get underneath the lamination though, so just checking. I had somebody drop, so I got a couple extras of these.
For calculations, if I get like answer,
It's fine.
the Casio.
Yeah, it's fine. Huh?
Who dropped? Shane Larson.
And it's been a long time. I'd have to look it up.
Oh,
Oh, I had 20 some. No, I had 26, I think, to start at the beginning of the year. I dropped a few people though. Like 2 or 3 of them had never had chemistry before, so they're pretty much automatic drops, unless I look and see that they've had like physics 1, 2, calc A, B, B, C. I mean, you know, they've got to be like
right.
way up there to be able to just streamline past. You're not going to be a sophomore, I can tell you that, taking AP
Right.
Chem. So, unless you've had chemistry
I was
already.
gonna say, they have one.
We have a couple, yeah. Maddie's not. Maddie's a
Maddie's in my
junior.
grade.
Yeah. So,
I've been here.
you may be my only sophomore this year.
Wow.
Last year I had several. Okay. So questions on this before we move into combustion analysis, and you're gonna want to kill me.
Oh, great. Thanks.
Mm-hmm. Well, here's my math for that.
Cool.
Look at yours is the restroom.
Sure. Minga, 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 minga.
I don't know what's brand. I don't like brand.
All right. We have a combustion analysis. Okay. Did I not give you this slide?
Sorry.
Find it, let me.
No.
Combustion analysis.
Let me see how far it goes.
Take a dog and pass it around. Here, give me half the dog so I can have the room. Anybody write big and you pieces?
I know.
You don't have to write all this down. I'm going to go through all of this with you. Okay? So don't write all of that down. We're going to do a sample problem together. Take a dog, pass it around. Flip it over. There's a dog. See?
Just 4 point something.
Ours are forms.
Question out.
Don't write all of that down. I'm going to show you how to do it. What?
It's like 4 point something.
No, this is still part of STOIC 4.5. Don't write all of this down. I'm going to show you how to do a problem.
Labeling it.
Okay. We will be here forever. All right, combustion analysis. This means that you're starting with a hydrocarbon. You're reacting it with what? Oxygen, and your two products are water and CO2. Now, like I said yesterday, in reality, you are actually going to be forming carbon monoxide as well. So make sure you open up your garage door before you start your car, because this is what happens. These combustion reactions are what happens in your combustion engine. Okay. I don't know how the batteries work, but that's a different story for a different day, y'all. We'll get to batteries at the end of the year, but not the fancy ones that Tesla uses. All right. So when we do these, they're telling us that we are starting out with an acid. The acid has carbon, hydrogen, and oxygen in it. And we're trying to give the empirical formula. Okay? So I've got carbon, I've got hydrogen, and I've got oxygen. I don't know what these X's are. I don't know what those subscripts are. That's what we're figuring out. Okay? We are going to react that with oxygen, and we are going to form carbon dioxide and water as our products. All right? They are telling us that we have 0.579 grams of this, and I have 0.142 grams of this. I can't balance my equation because I don't know this information here. Okay? But so if you're like, you have to balance the equation, I can't. Okay? So I know I can figure out the percent composition of carbon dioxide and the percent composition of water just by using my periodic table. Okay? So for CO2, I have 1 carbon times 12. That equals 12. I have 2 oxygens times 16.0. That equals 32.0. And I can add those together for a total of 44.0. Then I'm doing percent comp. What is the theme for any percent? Part over whole. Okay, so I'm going to take each of these parts and divide them by the whole. $12 divided by 44. You should get 27.3%. Okay. And then this other one is going to be 72.7%. All right. Now, I'm going to take these and I'm going to use them to figure out how much carbon and how much oxygen I have in this guy. Because 27% of this is the grams of carbon. And 72.7% of this is the grams of oxygen. Okay? So if I take these out of percent form and multiply them by this value, that's going to give me my grams of each of those. So that means that I'm going to have 0.157 grams of carbon, and I'm going to have 0.421 grams of oxygen. Anybody need another dog? Still got room? Okay. Now I'm going to do the same thing for water. So do the same thing for water with this value and tell me how many grams of each of those you have. Go. Do the percent comp of water and then figure out how many grams of hydrogen and water you got. Anybody not know how to do that? Already done? Okay. And here at laziness in school is just as somebody is smart. Where did say the other day? Right? Huh? I got the top kids that were being lazy on me. He was running the hair. It's still in there. There. Yeah, there you go. And there's one more right there. Right there. It's still there.
Okay.
All right. You got him? Presley, you got him?
Yeah, I got it.
All right. You should have figured out in all of that we have 11.1% hydrogen and 88.9% oxygen. Yes? Okay. So then, did you figure out the grams of each yet? Okay. So the grams of hydrogen, you should have ended up with 0.0158 grams of hydrogen. And I should have ended up with 0.126 grams of oxygen. Good?
0.10?
Zero. Yeah, this is a 0 here. If you would have like been calculating instead of playing with your hair.
Okay.
All right. So we're still not done. All right. No, we're not done. Okay. So you have figured out now. I'm going to get rid of all of this stuff here because it's kind of in my way. You keep it on your paper though. Okay. But I want to focus. Don't get rid of this stuff on your paper. Leave this on your paper. I just am clearing some word space to be able to talk. Okay. I don't want you erasing anything. You don't erase anything. All right. You know now how much carbon is in this compound. This compound has 0.157 grams of carbon. This compound has 0.0158 grams of hydrogen. This compound has, what do we have to do for the oxygen? We got it in 2 different spots here, y'all. We got to add it, okay? So you got to add that oxygen up to be able to get your grams of oxygen here. All right. Where did I get 0.126? I goofed my answer to you back in the day. Well, I gave my calculator away. So I got 0.421 plus 0.126. I got 0.547 here. Did I do these right?
I don't know.
Oh,
Yeah, 5, 4, 6.
yeah, 0.547. Okay. So for my oxygen, I got 0.547 grams of oxygen. Okay.
Can that be split up between like the hydrocarbon and
Oh crap, you're right. That's what I did wrong. So that's for all of this. Oh, but here. 0.3 grams sample. Oh, that's why. That's why. Okay. Okay. So, hold on. Ah, yes. Very good. Very good. Very good. Very good. Okay. That's my total oxygen. That's where I was like arguing with myself in my brain. Okay. So this is my total oxygen amount, which is 0.547. Okay. This compound, though, was only 0.3 grams. Okay. So I have to take the 0.3. I have to subtract out this amount and this amount, and what's left over is the grams of oxygen. Okay, so 0.3 minus 0.157 minus 0.0158. And that gives me, that's what I did. That's what I did. That's what I did. 0.126. We're still not done.
Is this a kind of question you see on the AP test?
Mhm.
Or
Oh no. Oh no.
you need to give me a week for the AP test?
Okay. Everybody caught up with me now, or no? Okay. Okay. So I know that my sample of this hydrocarbon, this whole thing here, is 0.3 grams. Okay. I know that this much is carbon and this much is hydrogen. So if I take these two amounts and subtract from 0.3, that's going to give me my grams of oxygen. I could not take it from here because we had this, as Gabe pointed out, we had this oxygen here. So it doesn't work. Grace.
So in a combustion analysis, you're always going to be like finding O2 that way.
Yes. Yeah, you'll have to because it occurs in both compounds. So you can't isolate which one or how much you have because you don't know what came from the carbon, what came from the hydrogen. All right. Everybody good with how I got this oxygen now? Okay. So now this is, I'm going to get rid of this stuff so I can have a little bit more board space to work with you. Anybody need another dog? Good? Okay. All right. So now we have to turn these things into moles. So I am going to divide this by 12. I'm going to divide this by 1. And I'm going to divide this by 16. That's going to give me my moles. Make sure you keep 3 sig figs here.
Sig figs is what killed me on this test last year.
It's going to be moles of carbon.
You just
Moles.
divided by 1 into your calculator, Libby.
Did I? No.
You like looked at your calculator.
No, I'm looking at my answer book here.
Oh, okay.
I've got all the answers right here.
Oh, I thought you were putting 0.0158 divided by 1 into your calculator, and
No.
it really is a Thursday.
Make a microscope.
Okay, shit. Like, don't get me wrong, I feel you.
Ben's been doing it the entire day.
All right. What is my next step?
Has any of my lab group done a single thing?
Do you need a new lab group?
No, we're talking about this.
Oh.
Teddy jumped in.
Divide by the smallest number. Yes. So I'm going to divide everything here by 0.0079 and divide by 0.00. That's 1. Okay. So I do that. I get a 6 here and I get a 5 here. These are thankfully whole numbers. So this is going to be C5H60. That is the answer. See why I gave you a dog instead of expected you to try to cram that in somewhere? Had to have a,
That'd be like a free response question, or would that be like a multiple choice?
yeah. And if I ran into one of those as a multiple choice, I'd skip it. And if I had time at the end, I'd go back to it. There's no sense in, they give you a minute and a half per question. You're never going to finish this guy at a minute and a half. Skip it. Come back if you have time. Okay? And back in the day when you didn't have a calculator, they gave you problems like this. It was a bear.
I think I
No, you skip it and you go on to another question. Okay? There is a hydrate question here. You guys can work through that on your own. You've done hydrates before. Go and look at the answer key. And then you've got I do's and we do's you can work on too. Okay? Lab tomorrow. Labby, 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 labby. Lab tomorrow. You labbing. You labbing about stoic tomorrow, y'all. And you're labbing about 8% yield too.
Okay.
Sir.
So like the hydrochloric acid and the methanol, we just put like the containers out. Is that how you want it? And then